To carry out the reaction to produce rubidium dichromate, what we're going to need is rubidium chloride and ammonium dichromate. I am using all of my rubidium chloride in this reaction, so I have written the protocol. I didn't write the protocol, obviously. This comes from the Handbook of Preparative Inorganic Chemistry. The full reference, I'm sure, will be on the screen to where you can find it yourself. But I figure this is a great trick in order to return the much more commonly available rubidium chloride into rubidium hydroxide. And the way that this would be done would be to convert the rubidium chloride into rubidium dichromate. Then you could adjust a solution of that, adjust the pH to create rubidium chromate, and then you could precipitate out the chromate with barium hydroxide. That would give you rubidium hydroxide, and then you could react rubidium hydroxide with any acid you want in order to get any rubidium salt you want. So this could be a great way in order to turn, the only, well, not the only starting, rubidium compound that's out there. I think I've seen rubidium bromide for sale as well. But I have not been able to find rubidium hydroxide or rubidium carbonate, which is what you need in order to do a lot of syntheses of rubidium compounds. Same thing is true for cesium. Now, you could absolutely use cesium chloride instead of rubidium chloride in this reaction. In the textbook, it points out that they're both done the same way. You just have to adjust the stoichiometry. So, with that, I'll go ahead and get the solutions made up, and I will tell you all how that's done. So I didn't have quite 25 grams of rubidium chloride after all. When I finally weighed it out, it was 21.82 grams. So I adjusted the amount of ammonium dichromate to 22.74 grams. Now, the protocol says to dissolve these in a minimal amount of warm water, and then it's just as simple as combining the two solutions, allowing it to cool, and rubidium dichromate should begin to crystallize out. The other product of the reaction, ammonium chloride, is extremely soluble and should remain in solution. I can't imagine how it would come out of solution. So I'm just going to go ahead and do this. I'm not really sure what warm water means, so we're just going to kind of wing it. And if you're wondering what this is all about, these trees, obviously it's fall and they are dropping some acorns, and man, some of them fall from pretty high up and they whack the bench with a good amount of force. So, so I don't lose my extremely expensive rubidium chloride. I really sparing no expense on this video because my subscribers are fucking worth it. Y'all rock. Alright, so this water is, and I even busted out the good deionized water for this experiment, mostly because I don't want anything else fucking it up. But I was getting that from a buddy of mine, and he moved, so I don't have access to that anymore either, and my stock of that is dwindling. Yeah, we're getting fairly poor here at the Poor Man's Chemist. But that's okay. We shall persevere. Being broke has absolutely never stopped me in the past. Alright, so rubidium chloride, very similar to sodium chloride, should dissolve in a fairly minimal amount of hot water. Let's try that. Again, no specified amounts of water are given, no specified temperature. So we're just going to go with it. Like I said, ideally we want to keep it to a bare minimum. I probably kind of overdid it there. About 50 mils, okay. I had anticipated using about 40 or 50 mils, so that's all right. The solubility of rubidium dichromate in water is, according to the textbook, it is 5% at 18 degrees Celsius. Okay, about 75 mils, that should do it. At least I hope that does it. Yes, I'm really missing my stir plate right about now. We're doing it like the old timers would have done way back in the olden days, when Ma and Pa chemists had to make do on the range. I don't even know where I'm going with that. That's coming from somewhere. I'm not really sure where. Okay. Apparently a little too much in the rubidium chloride and not quite enough on the ammonium dichromate. But again, that's alright. Okay. Everything is fully dissolved, so here we go. Oh wow, that didn't take long. Oh my god. Oh wow. Well shit, people. That's pretty awesome. Okay. I guess in this case, moderately means moderately. Alright, it is homogeneous and stirred up, and now the protocol says to just let it cool and settle. And I don't care about that stuff on the sides. There is no way in hell I'm adding water to this. Come on, get back down. Ah, screw it. I'll get it later. Oh, that is freaking awesome, man. Look at that. Holy crap. I did not anticipate that it was going to be that simple. Wow. That's pretty cool. I really hope that wasn't out of focus the whole time, because that would suck. Alright everyone, I have allowed the mixture of rubidium dichromate and the solution of ammonium chloride to chill down to, it's a little bit above 10 degrees C. I think it's like 13 or 14 degrees C. And I'm going to attempt to filter it by vacuum filtration. I'm not sure how this is going to go. But there's only one way to find out, huh? So, let's turn on the vacuum. And, yeah, check this shit out. I moved the aspirator over here. So much more convenient. We lost a stir plate, but we got fucking vacuum filtration. Alright. Let's hope it stays in place. Come on. Yes. That is fucking awesome. Sorry if I'm blocking the view. You see my big gloved hand getting this crap everywhere. It is not crap. It is fucking awesome. Look at that. It filters beautifully. You can't help but to love something that filters beautifully. That is so freaking awesome. So the plan is to dry it as much as I can here on the vacuum filter. And then what I'm going to do is I'm going to put it in the redneck desiccator overnight to dry over 3 angstrom molecular sieves. And those will dry the hell out of anything pretty quickly. So by tomorrow morning we should be ready for the next step. The next step involves calcining this at a very low temperature, since about 5% of this is actually still unreacted ammonium dichromate. So the protocol did mention that we would have to do that step. So I'm going to let this dry here on the vacuum filter as much as I can. Spread it out a little bit. Oh man, that is freaking awesome. That is just, I'm getting it everywhere. That's alright. I want to make sure I get it as dry as possible. And the filtrate here will be evaporated down. What I'm going to do is I'm going to put it in an evaporating dish and just try to evaporate it down to produce another crop of crystals. So all of this stuff that looks like I'm losing all over the place, I'm not. I'm going to I'll redissolve all this in water, add it to the filtrate, and then I'll get all the crystals back out of it. Oh, come here, you little fucker. Alright. It's the next morning, and this is our product after it's been drying overnight. I broke it up some this morning and then put it back in the desiccator for another few hours. So, I mean, it's as dry as I can get it in the time I've had since I started this. So now the next step in the protocol is to decompose the remaining ammonium dichromate that is left in here. According to the textbook, it's supposed to be about 5%. Now, I looked up the decomposition temperature of ammonium dichromate, and it's only 180 degrees Celsius, so I am going to try using my trusty lab toaster oven for this, since that's a temperature it can easily hit, and I have more control over the temperature doing it this way. At such a low temp, I don't feel comfortable. Oh, of course that happened when I was filming. I don't feel comfortable trying to do it over a flame. Ammonium dichromate can also decompose rather vigorously. So not knowing exactly what to expect here, I'm not going to do all of this at once. I'm going to take a portion of it, I'm going to put it in this evaporating dish, and I'm going to put it in here, and we're going to give it a run here for a little while, and we're going to see what happens. So, fingers crossed that it's uneventful, except for the decomposition of ammonium dichromate, because I don't want that shit in my rubidium dichromate. So, anyway, I'm going to go ahead and get that started, and I'll come back when something happens that's worth noting. Okay, so I have had the rubidium dichromate calcining in the toaster oven for an hour now. I upped the temperature from 375 to 400 after looking up some other stuff online, and I figured that that's not going to decompose the rubidium dichromate. Fingers crossed. So anyway, let's take it out and let's see what it looks like. I don't know what the hell that white stuff is. Okay. Alrighty then. No clue what the hell that was. Okay, I've had this sitting out for just a few minutes here so it can cool off. Sorry for the interruption. FedEx showed up, of course, because I was ready to take this thing out of the oven, so naturally they showed up. So like I was saying before, I think what will happen here is that ammonium dichromate will decompose to chromium 3 oxide. Chromium 3 oxide is not soluble in water, so we should be able to dissolve the rubidium dichromate and then separate the chromium trioxide from that pretty easily just by filtering it. And yes, I'm wearing the dust mask and everything just because, you know, it was a dry dichromate. I didn't want to take any chances. See, I do take safety seriously. And I will absolutely use PPE when it is warranted. Chromium 6, yeah, kind of warranted. And I'm not saying it's not warranted with lead. I was just saying that video, I was just saying it wasn't warranted with lead dioxide while we were outside. But we didn't have to stand over the lead dioxide like we do this. So, you know, there's a big difference there. Alright. I doubt that's got all of the rubidium dichromate dissolved, but I'm going to go ahead and filter this, and then I will wash the filtrate very thoroughly just to make sure I get it all, and then we will evaporate it down to recrystallize it, and that should give us pure rubidium dichromate. So let me go get it all set up for filtration, and I'll be back when we're ready to do that. Okay, so I've got the calcine product here filtering into this Erlenmeyer flask. Just to be on the safe side, I have been running everything that comes through there through a submicron filter. What are these? These have a pore size of 0.2 micrometers. So yeah, they're pretty good. Very expensive. I've been holding on to those for a long time. I only get them out for the really good stuff. So anyway, but I want to be absolutely sure that I am excluding as much of the chromium trioxide as possible. Although, to be honest, I haven't really had a hard time filtering it out. You can see this is what I've got so far. I went ahead and started it evaporating. And so all of that has been pushed through. It'll focus for me. This filter here, and it's really not that dirty at all. So these the chromium trioxide particles produced by the decomposition of the ammonium dichromate have got to be of a pretty decent size, because it's not really hard to filter them out. So anyway, theoretically, this is our highly pure rubidium dichromate, so now it's just a matter of evaporating out the water and allowing it to crystallize. And I'm just going to do that on this boiling water bath here and just let it take its time so that I can get some nice crystals out of this. And yeah, once we get some crystals here, that'll be it. So fingers crossed, and I'll come back when there's something to show you with this. Okay, so I evaporated down the calcine product, the filtrate from the calcine product, and this is what I've got. It still has some ammonium chloride in it. Basically what I've figured out since actually doing this and seeing how it goes is that the calcination needs to be done at a higher temperature. I think, and this, I stress I think, that a temperature closer to about 350 C is probably going to be better. Because at that temperature, you shouldn't decompose the rubidium dichromate, but it should be sufficiently hot to drive off any remaining ammonium chloride. So, I mean, yeah, that would be the only thing that I would change, is do the calcination at a somewhat higher temperature than what I did. But, I mean, having said that, I mean, you would still have expected it to drive out some ammonium chloride, even heating it like I did. And as you'll see if you stick around after the end, as usual, there are pictures of this product and the crude product that I took under the dissection scope. And I mean, there you can tell a big difference between the crude product and this product. Yeah, you'll see. Like I said, stick around after the end of the video and you'll be able to see the difference. But anyway, so this is it, man. This is, as far as I can tell, this is pretty damn pure rubidium dichromate. And I mean, the only other thing that I could think that I could possibly do with it would be to give it another run, calcine at a slightly higher temperature, just to make sure I drove off the last little bits of ammonium chloride. But, I mean, as far as I'm concerned, I mean, this is pretty much good enough. I mean, it doesn't have to be, you know, absolutely pure, unless I decide to sell some of this, in which case, you know, yes, I would go through and do the extra calcination step, because there's no way in hell I'm going to sell anything, you know, that I don't feel is of a decent purity. But anyway, so that's basically it. If you've enjoyed this, please leave the video, you know, give it a like. If you didn't like it, give it a dislike. Please leave a comment. Tell me how awesome I am, or tell me how much I'm fucking suck. And, yeah, and if you think I've earned it, you know, subscribe. The more the merrier, man. Would love to have you on board. And, if you don't mind sharing the video, that would also be very helpful. But anyway, yeah, so I hope you all have enjoyed this, and until the next video, y'all, we'll see you later.